Viruses have been a huge part of our lives this past year. But did you know that we can harness the mechanisms of viruses for our own benefit? Here at GetGenics, we utilize particles called lentiviral vectors, or LVs, that use the envelopes of viruses to package genetic material. This genetic material can then be used to solve rare diseases, such as beta thalassemia. While I can bore you with the whole process, we'll start at the very beginning instead. LVs are produced from cells, so in order to create clinically relevant amounts of LVs, we need to grow up a lot of cells. This is done in the seed train, a series of progressively larger vessels. In order to plan for the seed train, we first need to get a better understanding on the science behind cell growth. Cell growth can be modeled simply by taking into account the doubling time of your cells. While this can give rough estimates for the time it takes to grow up a certain amount of cells, this is only a simple model. For our process, we want something more detailed. This is where monod kinetics comes in. It takes into account many more parameters aside from doubling time. This time around, growth is dependent on concentrations of metabolites, and cell death is factored in. The system of ODEs that makes up monod kinetics was solved using MATLAB. As seen in the graph to the right, this gave us a more accurate model for cell growth. After a certain amount of time, nutrients are used up and cells start to die. This is seen by the dip in the curve. Another model was used to validate the monod results. This was the logistic equations. Due to limited data on our specific cell line, experimental data was fitted to find the cell-specific parameters. While there are differences when the two models are plotted against one another, the part we are interested in is around 60 hours. This is when max cell density is reached in the vessel. At this portion, there is about a 15% difference in the number of cells. But due to the models being inherently different, we found that this was close enough to validate our monod results. Now that our cell growth model is defined, the whole seed train can be created. Once cells reach a certain density, they are passaged onto the next larger vessel, and this process is repeated until the target cell number is reached. Moving forward, further changes can be implemented to refine and optimize the model. One example is the inclusion of pH. A new growth rate was implemented into the system of ODEs to take into account the effect of pH within the system. Thank you for listening. For more information on cell growth kinetics or lentiviral vectors, feel free to reach out to us at GetGenics.